Question 16. Shane estimated the distance between Cardiff and Swansea is 40 miles and his average speed would be 60 miles per hour. He estimated the distance to the nearest 5 and the speed to the nearest 10. And we want the upper bound for the time of the journey it should take. So we are doing speed equals distance over time. That's the formula. And we want the formula rewritten for time. So if I rewrite that, time is equal to distance divided by speed. So the time upper bound will be equal to the largest numerator, smallest denominator. So the distance, we want the upper of the distance divided by the lower for the speed. So let's look at the distance. So the distance, he estimates it to be 40 miles. And this is to the nearest 5. So the upper bound on that would be 42.5 miles. So we're going to use that figure there. For the speed, he estimates the speed to be 60 miles per hour, and that's to the nearest 10. We want the lower bound, so our lower bound will be 55 miles per hour. We want to use that figure. So back to our formula. The upper bound for the time will be the largest distance, 42.5, divided by the slowest speed, 55, and 42.5 divided by 55 will give you an answer of 0.77 hours. That's not an unpleasant result to put down. We don't quote time in that sort of way. So let's turn that into minutes. So 0.77 hours is equal to 0.77 multiplied by 60 minutes. So leaving the whole number in my calculator, times by 60, and I get the answer of 46.4 minutes. So 46 minutes would probably suffice for the question. Okay, in this question we have a solid metal sphere with a radius of 4 centimeters to one significant figure. The sphere has a mass of 1,200 grams to 2 significant figures. And we work out the lower bound for the density of the metal. So density is the first thing that jumps off the page for that. Density is a formula you should know. Density is mass divided by volume. We want the lower bound for the density. So again, for this fraction to be the lowest it can be, we're going to want the lowest mass, so the lower bound for the mass divided by the biggest volume. So the upper bound for the volume. Okay, volume of a sphere. The volume of a sphere is 4/3 pi r cubed. You will be given that in a GCSE exam. And we know that the radius is 4 centimeters to one significant figure. And we want it to be the upper bound of that. So we want the V upper. So we want the radius upper. We want the highest possible radius. So the radius is 4 centimeters to one significant figure. So it's going to be 4.5 centimeters will be the upper bound for that. Because as you know, the next one significant number after 4 is going to be 5. Halfway between is 4.5. So 4.5 is the upper bound of the radius. So let's just calculate that. So we've got the volume upper is going to be equals to 4/3 pi times 4.5 cubed. Put that into the calculator. 4 divided by 3 multiplied by pi multiplied by 4.5 cubed, and I get the answer of 381.7035, so 7. I'll leave it at 7, but I'm going to try and leave the number in my calculator if I can get away with it. Now, that's the volume. What's the mass? The mass is equal to 1,200 grams to two significant figures. So, actually, let me just rewrite that like this. The mass is 1,200 grams to two significant figures, 2SF. I want it to be as small as possible. So, again, I got 1,200. So, below that, we would have 1,100. Halfway then would be 1,150 grams. That would be my bound. That number I've circled there, rounded to two significant figures, would go to 1,200. So that's my lower bound for the mass. So my density lower will be my lowest bound for the mass, which is 1150. I would divide by the upper bound for the volume, which is 381.7. And this gives a final answer of 3.01. And the units there are grams per centimeters cubed. Question 18, you're using a formula you should be familiar with, which is V equals U plus AT. It's a velocity formula. And we are looking for the upper bound of T. So if we take our formula, V equals U plus AT, let's rearrange it first for T. So we'll take the U over to the left-hand side, so V minus U equals AT, and then T will be equal to V minus U divided by A. Now we have it in that form. We're looking for the upper bound. So for this to be true, what do we need to have? With our fraction here, we need to have, for it to be the largest possible value, we need the smallest possible value at the bottom, and we want the largest, okay, or the upper value for the top. But the top has got a subtraction on it, so we need to break that down. So for the, we'll leave the bottom as the lower, we know that's going to be the case. For a subtraction, for a difference, we are going to need the largest value take away the smallest value. Just think about that for a second. If we have the largest value of V take away the smallest value of U, that will give us the largest possible value at the top. Dividing by the lowest possible value for A will give us the greatest possible value for our fraction. So, just to summarize that, what I'm going to need V upper, I'm going to need U lower, and I'm going to need A lower. So let's look at V. V is 25.32 to 2 decimal places, and I want the upper bound of that. So that's going to give me 25.325. That's my upper bound. Because again, anything from this point onwards to 2 decimal places would round upwards. So that's my upper bound. My lower bound then for U. U is 5.4, and that's to 1 decimal place. And I want the lower bound, so I'm going to go to 5.45. Again, because, sorry, 5.35, my mistake. That's the lower bound, because anything below that would round down to 5.3 to 1 decimal place. And finally, I want my A value, and that's going to be in the lower bound again. So my A value is 4.9 to 1 decimal place. So again, that's going to be 4.85, because anything below that would round down to 4.8. So those are my three values that I'm going to be using. I'm going to be using 25.3, 5.35, and 4.85. So I now want to finish this off. So my T upper is going to be equal to my V upper minus my U lower divided by my A lower. You don't need to write that line in, but I'm just putting it in there just to hopefully make it a little bit clearer for you. So the V upper is 25.325. Take away 5.35 all over 4.85, and hopefully when I put this into the calculator, I'll get the right answer. So 25.325 subtract 5.35. Let me just put that point back in there a bit more clearer. That's going to give me 19.975. Divide that by 4.85, and I get a final answer of 4.1186 seconds. And the final question. This one involves population density. Population density is similar to density. Density is mass divided by volume. Population density is the number of people, so the population, divided by the area. So we want the lower bound for population density, so we want the PD lower. I'm going to use PD for population density. So that's going to be from this fraction here. So for that to be the smallest possible thing I want the population to be the lowest, and I want the area to be the greatest. Okay, so the lowest population and the upper area. That will give me the lowest possible value for the fraction, therefore the lowest possible population density. So the population is 6.4 times 10 to the 6. Now I don't want to use the standard form for this particular question. I think it's confusing, so I'm going to write that out in full. So that's 6400000. Let me just check I have enough zeros there. We've moved from the decimal point position. We've gone 1, 2, 3, 4, 5, 6 times. So that number is fine, and that is correct to the nearest 100,000. To nearest 100,000. So therefore, my lower bound will be 50,000 less than my 6.4 million. So it's going to be 6,350,000. If I add on 50,000 to this, it takes you back to here. This is my boundary. It's my lower bound. Now let's look at the area. The area is 8.4 times 10 to the 4. Again, let's get rid of the standard form. So that's going to be 84000, and this is to the nearest 100 kilometers. And I want the upper bound for this one. So I half my 100 to 50. So my answer is going to be, my upper bound is going to be 84050. These are the two numbers that I will use in my equation over here. So my population density lower, I want the lowest population, which is 6350000, divided by my area, which is my upper area, which is 84050. And when I put that into the calculator, I should get 75.55. And the units we can put on this will be people per kilometre squared.